Welcome to yet another class. I'm Dr. B. Today I'm going to take us through the periodic table. We are going to see how the periodic table is being described. So we're going to describe a few properties of the periodic table that would be of interest to us. Now the periodic table looks like this. We are going to fill in some of the elements in the periodic table to be able to explain the trends in the periodic table. Now, from here we have hydrogen, we have helium, we have lithium, we have beryllium, we have boron, hydrogen, helium, lithium, barium, and neon, okay, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, argon, potassium, calcium. Here we have scandium, titanium, vanadium, chromium, manganese. Okay, so we have iron, we have cobalt, we have nickel. Is this complete? Because we have copper and we have zinc somewhere. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9. Wow, we're supposed to have 10. So let's just manage it that way. So we have zinc. So at this point here we have gallium, we have germanium, we also have arsenic. Okay, we have cerium, and then we have bromine, and then here at the end we have another type of noble gas. All right, so we have them, okay, over and over. We can probably fill the whole of this, but for want of time we could just stop somewhere. All right, now what is interesting about the periodic table is not just about the arrangement of these elements in their increasing atomic numbers as we move from the left to the right of the across the period. Now it's interesting for us to know that the periodic table is divided into about 4 regions, and those regions can be seen here. That the first region is the S block elements. That is the first region. And then the second region is here. And the second region happens to be the P block elements. Okay? And then the third region is here. And that is the D block elements. And the last region is here. And that is the what? The F block elements. So you see that we have the S block elements, the P block elements, the D block elements, and the F block elements. And with this, it is obvious that your electronic configuration of elements is derived from these various names or regions. Okay, so we could have also krypton. So let me just complete that. All right, krypton. Now, it is very obvious that your electronic configuration, where you have 1s2, 2s2, 2p6, 3s2, 3pd, 3d that, all of them come from what? They come from the different blocks, the different regions of the periodic table. So the periodic table is divided into 4 basic regions: the S block, D block, P block, and the F block elements. Now, if you look at the periodic table is also divided into groups and periods. Now, here we have groups. That is, looking from this side coming down, we have what? Groups. And then this side, looking from left to right, we have what we call the periods. What we call the periods. So these are the periods. The lines running horizontally from left to right are the period in the periodic table, while the lines running from top down vertically are what they are, the groups. Now we have about 8 groups in the periodic table, and this is group 1, this is group 2, this is group 3, this is group 4, this is group 5, this is group 6, and this is group 7. This will have been group 8, but we call it 0. And this is because these are noble gases. They take the noble gas configuration. It means that they are inert gases. They are octet in their electronic configuration. That means they have all their shells completely filled. Very difficult for them to carry out any or to involve in any kind of a reaction, but they still do to an extent. So this group of elements are always termed the noble gases. They have octet electronic configuration. They have a completely filled orbitals. Now these are 1, 2, 3, 4, 5, 6, 7, and 8 various groups of the periodic table. And we have the period running from left to right. So we have 1, we have 2, we have 3, we have 4, we have 5, we have 6, we have 7 period. Okay, 1, 2, 3, 4, 5, 6, 7. We have 7 period. Now interestingly, we need to know that the period, the 7th period of the periodic table ends somewhere in chromium. Okay, ends somewhere in chromium. So this is how the periodic table presents itself. So we have 8 groups in the periodic table, with the 8th group named as 0 being the noble gases, and we have 7 periods in the periodic table. Right, and then like I said before, we have 4 different regions that are called blocks, which are the S block, D block, P block, and the F block of their periodic table. It's good for us to know that the S block of the periodic table are always metals, and these are the group 1 and the group 2 of the periodic table. Then you have the D block, which are the transition metals, and we have had a class on this already. And then you have the P block, which of course they are more of metalloids and non-metals. Metalloids means that they possess the qualities of both metals and non-metals, and we also have non-metals inclusive. And the F block are what? The lanthanides. Are the lanthanides and the actinides. And the actinides. So we have the lanthanides and the actinides. They form the F block elements. Interestingly, we are going to take a look at some properties of this periodic table. Now, it will interest you to know that these S block elements that are group 1 and group 2 are called alkali metals, and what? The alkali earth metals. Why? Why are group 1 elements called alkali metals and the group 2 elements are called alkaline earth metals? This is because the group 1 elements have a strong tendency to react with water and give us alkalis. So the name alkali metal comes from the fact that they can react with water and give us a product that is called alkalis. Now, for the group 2, they are the alkaline earth metals. Why are they called that way? It is because they also have the potential to react with water, but they have very little tendency of producing alkalis. So we call them what? Alkaline earth metals. So group 1 elements in the S block are called alkali metals because they have a stronger tendency of reacting with water to form alkalis. And the group 2 elements in the S block are called the alkaline earth metals because though they react with water to form alkalis, but very little. Now, in the group 1 elements, we need to understand that both group 1 and group 2 elements are metals. So if you are moving generally from the top of the group to the bottom of the group across the entire periodic table, there is an increasing metallic nature of the elements. So if you are coming from up going down, you will be seeing an increase in the metallic nature of what? Of elements. And because of that, the group 1 and group 2 elements are very strong what? Reducing agents. So if you move from up the group, top of the group, going down the group, you are meeting a stronger reducing agent. So hydrogen is a reducing agent. Lithium is more stronger as a reducing agent compared to hydrogen. Sodium is more stronger compared to what? To the hydrogen. And this is because of what? The shielding effects that you have. We've discussed shielding effect before. So because of the shielding effects that you have as you come down the group, you have a tendency of having what? A stronger reducing agent. Now, if you are moving across the period from left to right, there is a tendency of what? Of increasing non-metallic nature. So metals are more to the left, and non-metals and metalloids are more to the right. So if you are moving this way, you have more of non-metals and metalloids. Like I said, metalloids possess the properties of both metals and non-metals, while the non-metals are completely non-metals. For example, if you take a look, if you are moving from here to here, you see boron is here, okay? Right, you see boron is here, you see silicon is here, you see germanium is here. All these are what? They are metalloids. And if you move and continue, you see fluorine, chlorine, bromine, they are all non-metals. So if you are moving from your left of the periodic table across the period, going to the right, there is an increasing metalloid and non-metals. Right, there's a striking importance, silicon and germanium. They are, though they are what? They are metalloids, they are also very good semiconductors. Take note of that. That silicon and germanium are very good what? Semiconductors as metalloids. Now, that is certain. We need to understand another thing about the group 7 elements. Group 7 elements are the elements in the periodic table that show very strong characteristics of non-metals. All of them are what? Non-metals. And because they are non-metals, they are very good oxidizing agents. We must understand that while group 1 and group 2 elements that are S block elements are good what? Are good reducing agents, especially as you move from top of the group down the group. The group 7 elements that are called halogens are very good oxidizing agents. So halogens as group 7 elements, as you move from top of the group going down, there is a reduction in the oxidizing tendency. So it means that fluorine has the highest oxidation power, and this is also because of what is effective nuclear charge. So it has the highest of this oxidizing tendency. So chlorine is less oxidizing to fluorine, and bromine is less oxidizing to chlorine. So the highest oxidizing power is from the top of the group going down. You have a lesser oxidizing power. This is different from what we talk about in the reducing power. In the group 1, group 2, as you move down, the reducing power of these metals is rather what? Increased as reducing agents. Now I want us to know that if you take a look at the periodic table as a whole, okay, as a whole, the effective nuclear charge of these elements, if you move from the top of the group going down, increases. What do we mean by that? I know I've discussed this in our earlier classes. It means that the force which binds these electrons at this shell closer to the nucleus does what? Is what is increased. So they have strong nuclear charges. And the same thing happens with shielding effect. If you are moving from top of the group going down the group, you'll be having an increase in shielding. And know that if you have an increase in shielding, that means the electrons that are at the top of the shells will be shielded by the ones that are in the shells below, shielding them away from what the powers of the forces of the attraction of the nucleus. By that, it means that they can easily pull out of their shells. Therefore, we can say that the ionization energy will reduce as you move from top of the group going down. And we also say that the metallic nature of these elements also will increase as you move from top of the group going down. And that is not all. Other properties are like. But when you are moving across the period, you expect what? You are going to expect that the ionization energy will do what? Will increase as you move from what? Left to right. And that increase is because of the reduction in the shielding effect of the various nucleus, the various shells with respect to the nucleus. And of course, the atomic radius will also do what? Increase as you move from what? The left part of your periodic table across the period going toward the right side. Now, if we take a look at this, we'll understand that the S block elements are basically metals. And then the D block elements are what? The transition metals. We have discussed that already, that they have the ability to form complexes with ligands. They also have the ability as transition metals to form colored compounds. And they also have the ability to possess variable oxidation states. We have discussed on this exhaustively in our previous classes. Now again, if you look at the P block elements, like we said, they are metalloids and also non-metals. And then you look at the F block, that are basically the lanthanides and the actinides, containing mostly the radioactive metals. Like uranium, you can find it here. Okay. And like radium, you can find it here. Like thorium, you can find it here. And these are the F block elements. Now with this summary that we have gained here, I'm sure we've been able to understand some basic meanings or some basic properties that govern the periodic table. We have been able to understand what happens when you move from left to right of the periodic table, or when you move from up coming down the group of the periodic table. But do not forget that, like I said, periodic table is divided into 4 basic groups or regions: S block, D block, P block, and the F block. S block are basically metals, the P block are basically non-metals and metalloids, the D block are basically the transition metals, and the F block are the lanthanides and the actinides, more of what? Radioactive metals. Do not also forget that I have mentioned that as metalloid, silicon and germanium are very important in their properties, that though they are metalloids, they are also what? Semiconductors, and we're going to have a class on that as we proceed. And then do not forget that I said we have in the periodic table, we have 8 groupings in the periodic table, of which the 8 is actually recorded as 0, which is the noble gases. They have a completely filled valence. Their shells are completely filled, so they are octet in nature. And then we also say that we have 7 periods in the periodic table, and that as you move from left going to right across the period, there is an increasing non-metallic nature. As you move from top of the group coming down across the periodic table, there is also an increasing metallic nature. That the group 1 elements are basically reducing agents, especially increasing as you move from top coming down, and that the group 7 element, the halogens, are good oxidizing agents and reduces in their oxidation nature as we move from top of the group down to the group. I'm sure we've learned something interesting today as far as the periodic table is concerned. Do not forget to Don't forget to share, don't forget to like, don't forget to subscribe my YouTube channel, follow my YouTube page, make your comments known and they'll all be attended to. Till next time, when we shall take each of these group SPDF to discuss, it is bye for now.